Hello everybody, so welcome to our YouTube channel again, welcome to iScholar again. So in the last class what we have done is very important questions for the chapter electricity. Today in this session we are going to continue to that. We are going to discuss some more important question for the same chapter electricity for your boards exam. So let's get started. This is a brief introduction about my name is Shivani and I am the physics faculty here in iScholar. Okay, so coming to the first question, and this one is really very important one. Plus, I'll tell you what students do mistake. What is the common mistake done in this? Okay, so let us just look at this question. So we have a wire whose resistance is 1 ohm. Is stretched to double its length, and you have to calculate the value of the new resistance. Okay, so what is the common mistake done by all students? What do they do is, resistance is 1. Since the length is getting doubled, and we know that length and resistance are directly proportional, what is a common mistake done by them is, the new resistance would be just the twice. They just multiply it, that would be just twice of the initial resistance. But students, this is not correct and you are not going to do this mistake. Why it is not correct is, see, when we say that resistance is equals to rho L by A. So here we are saying that the length gets doubled. We can only just write it as when resistance is directly proportional to length when all the other parameters are constant. But clearly we can say that L is changing. Since the material is same, rho would be same. But what about the area? See, when are we going to stretch this wire? When I stretch this wire, what is going to happen? You'll say that, ma'am, the length of this wire will change, plus there will be also a change in the area of the wire. When you're going to pull it, the length of the body is increasing while area is going to contract. You're going to pull it, you're pulling it like this and the area is contracting. So can we say that? Can we just simply use this equation? You'll say that no. Since the area is also changed, we need to calculate what is the impact on this. So let's see how we can do. Okay. So now the wire is stretched to double its length. Students, can I say that if a wire is being stretched, this only means that whatever be the initial volume of the wire would be the same or would be the final volume of the wire. We are going to have the same volume for both of these wires. Obviously, if you're stretching it, the area is getting contracted, but the volume is have to be the same thing. Okay, so I'm writing the initial volume is initial area of the wire into the initial length of the wire is equals to, what is the final volume? You will say the final volume would be A dash, which we are trying to calculate into the length. Since the length is, we have stretched to make double of its length. So I'm writing the length would be twice of L2L. So from here, can I say that the new area would be just got as initial by 2, that is the new area after stretching, which is A dash, is got as the original area A divided by 2, as simple as that. Okay, now the final length, we know that it is double of its length, so the final length after stretching is twice of its length, and I'm showing this over here. Okay, so I'm just using all these values and we'll get over here that resistance after stretching the resistance, which I am referring as R dash, would be R into the new length I am showing by L dash and the new area which I am showing by A dash. So I showed all the values. Now we'll be writing it as the new resistance would be as rho, which is a constant quantity as the material is same. Until and unless you have the same material, it won't change. Into the length, what is happening to the length? That is 2 of L divided by area, that is initial area, divided by 2, which will go over here. So can I write from here that R dash, the new resistance after stretching, would be just 4 into rho into L divided by A. Now we know that what is rho L by E? That is the initial resistance, students. So we are going to say R dash is equals to 4 times of R. That is, when you stretch the wire to double its length, what is happening is the resistance, the new resistance, get 4 times of the initial one. I hope this question is clear. And I also hope that you'll never ever commit the mistake again. Okay, coming to the next question. Okay, so next question is, we have, why is fuse wire always connected in the live wire? Okay, so for first we'll understand what is this fuse wire. Now what is this fuse? Fuse is a safety apparatus which is connected in your homes. What it actually does is, when we have an immense amount of current flow, or when the circuit is short circuited due to any reason, so in such cases, if the current constantly goes in the similar way, this will definitely damage our home appliances. So fuse is a safety material made up of low melting point. So whenever current exceeds a certain value, it fuses out. It just burns out. It just breaks the circuit. After that, no current passes. So as simple as that, it is a safety equipment. Okay. Now why it is always connected in the live wire? See, live wire is the wire from which we get the direct current. This is because of the live wire which is used in our homes, so that the direct current passes from these wires. Now why is fuse always connected to live wire? Because as soon as the fuse melts or the fuse blows away, so we'll say that immediately, on an immediate basis, it will lose the contact with the live wire. Immediately, if it loses the contact with the live wire, immediately the passage of current would stop and no further current would be passing. So we'll say that why is fuse always connected? So that the flow of current you can write in the similar way in your exam. The flow of current is immediately stopped. Immediately stop in your home apparatus, so that no further current goes into your home apparatus, to your house appliances. And when no further current would go, we can simply say that no much damage will be. So for the best use of the fuse wire, it is always connected in the live wire. Okay, I hope this question is clear to you all. Moving to the next slide. Okay, so the next slide says that name a device which is used to maintain a potential difference between the ends of the conductor, and this is a asked question. This have been asked into your exam, which is used to maintain a potential difference between the ends of conductor. Okay, so how can you say that? The device which is used to maintain a potential difference is either you can use a cell or you can use a battery. You can write anything over here. Battery and cell both have the same purpose. Its purpose is to provide the potential difference between the ends of the conductor. It is because of all this that the current is flowing into the circuit. And in the last video, we have already discussed for the potential difference and what is potential. So do refer to that also. Now coming to the next slide is, list the advantages of connecting electrical devices in a parallel with electric source instead of connecting them in series. Okay, so first thing which we all know is, all the apparatus in our homes are connected in parallel only. Now why do we connect them in parallel? First, see, if all the appliances are connected in parallel, let's suppose this is different resistor I'm showing. Okay, they all are connected in parallel in such a way. Okay, so let me just make the first combination. Okay. Yeah. So So we have these all are the different resistors which are connected over here, and this is connected to them. Now let us suppose if any of the appliances stops working. So what will happen? If let's suppose this stops working, so no impact would be created on the other two. They would work in the same function. They would go in a similar way. So first thing which I am writing over here is others appliances do not stop working. Appliances do not stop working if one of them get faulty or if one of them is destroyed. Do not stop working. Do not stop working if one of them is faulty. Okay. Second is it is easily manageable. For example, now if one of the appliances is faulty, it has stopped working, we can easily change it. Right? So again I am saying easily manageable. Now the third point which I am writing is the important point, that is, see, if all these are connected in parallel, we know that all these are connected in parallel means that for everyone we are going to have same voltage difference. For each of these we are going to have same potential. They will be at same potential difference. So what I'm saying that when they have same potential difference, so every device, every appliances will work in an optimal condition since they have same potential difference. If you make them in series, voltages given to them would be different. And if voltages are different, we'll say that someone would be getting more, someone would be getting less. So easily they will not be working in that optimal condition. So I'm writing every appliances will work in an optimal condition. Every will work in an optimal condition. Okay, I hope this question is clear to you all. Now coming to the next slide. So this is a wire have a resistance 16 ohm. It is melted and drawn into a wire of half of its original length. So this question is quite similar to the stretching one. Why? In both the cases, students, pay attention. The volume is constant, no? Volume is constant in both the cases. So in that, when we were stretching, the area and length was changing. Similarly, when we are melting, again the same case. Okay, same, I'm giving you this hint, the volume would be constant, and now this one would be a homework for today, and you'll write the answer in the comment box. Next is a 9 ohm resistance wire is cut into 3 equal parts. Find the resistance if they are connected in parallel. Okay, so we have 9 ohm resistance. Now it is cut into 3 equal parts. Okay, this question is different from the questions we have discussed previously. Why? The resistance over here is rho L by A. In this time, we are cutting the wire, making sure that no other parameter is being changed. We are not changing the area of the resistance. We are not stretching or doing any other configuration. We are just simply cutting it. So what I'm saying, this time resistance is directly proportional to length, while all the parameters are constant. If R is directly proportional to length, which means that if you cut into 3 equal parts, so the resistance will also get 1/3, or the new resistance would be just 1/3 of the previous one. Why? You just cutted it into 3 equal parts. So the resistance just got 1/3. Okay. Now we know that the value of resistance is R by 3, R by 3 and R by 3, which is R by 3 of the first one, and they are connected in parallel finally. So I'm writing this would be again R by 3, again R by 3, R by 3. Now these all are connected in parallel, which they are connected to the battery over here. Now it is asked calculate the total resistance. So we know that if three things, if they all are cut into parallel parts and now they are in parallel, we can just say simply that the total resistance value now after this would be R dash is the total resistance would be, since they all are same, I am writing the value over here, divided by number of time you have used them. So we are going to write it as, since they are 3 times, so I am writing it over here as 3. The total value for the resistance will be given as R by 9. And we know that the initially resistance value is 9 ohm, which is given to you students. So just putting over here, the R dash value would be 9 by 9, that is 1 ohm. I hope this question is clear to you all. Pay attention to this type whenever it is melted and whenever it is just simply cutted. Okay, so coming to the next slide. Okay, so in the next question it is given that 2 lamp, one is rated 60 volt and 220 volt, and the another one is 40 volt and 220 volt are connected in parallel. Which one will glow brighter? Okay. So first of all, I am trying to calculate the resistance of both the lamps. So we know that, simply I'll write it over here, that is, for calculating the value of resistor, we are going to say it as power is equals to V square by R. What is P? The power of the lamps. What is V? The voltages of lamp. And what is R? The resistance. So I calculated the resistance of the first lamp, which would be 220 square divided by the power of first, that is 60. Similarly, calculating the value for the second one, which would be R2 is equals to, again, the voltages would be 220 square divided by the power, which is 40. Okay. So now, this is for the first, this is for resistance for the first lamp and resistance for the second one. Now tell me students, can I say that this resistance would be small as compared to this? Can I say that if I compare both these, since the denominator is more, the numerator would be small. Since the denominator over here is big, or we can say that the resistance value would be small. Similarly, the resistance is less. Can we say that this denominator is less? Can we say that the value of resistor would be more? Now, we have two bulbs. One is having a small resistance, another one is having the higher resistance. Now, tell me which one will glow brighter? Obviously, the one which have the low resistance. The bulb which have the low resistance will glow brighter as compared to the other one which have more resistance. I hope this is clear to you. If a current is increased by 100%, then calculate the increase in the power dissipated. Okay, so let's see this question. So the current is increased by 100%. Okay, so let us suppose our initial current is I. When you increase the current by 100%, what would be your final current? Your final current is whatever be the initial current plus it is increased by. Students, pay attention, it is by. By means whatever be the value plus add by how much amount you are adding. So it is 100%. 100%. So to remove the percent, I am dividing by 100 into what is the quantity which you are changing. That is I. So you are writing the final value of current is I plus I. The final value of current is 2I. So I'm just writing the final value of current is 2I. So initially the current was I, and after that the current became 2I. Okay. What is asked? Calculate the increase in power dissipated. So we know that the power dissipated, okay, so we know that is simply I square by R, because the resistance is kept constant. So I'm using the value for power as this, because R is constant in this, only I is changing. So can I say that the final power would be just 4I square into R. This is the initial power and this is the final power. Okay, what is asked? It is asked, calculate the increase in power dissipated. So can we say like this, the final power minus the initial power divided by the initial power into 100. Whenever you have to write for the power, whenever you have to write in this increase in power dissipated, first you will write the increase, the change which have came. If you are writing in the fraction format, you will write the initial one and then you will multiply by 100. So what is P dash minus P? Students, that is 3I square R divided by, what is the initial power? I square into R into 100. So you will just multiply this and you will get it has to be 300%. I hope this question is clear to all of you. And that is it for today's class. I hope you would have enjoyed the session and also you would have understood each and every topic. All the best, all the very best for your exam. Thank you, students.